parameters are passed to functions in Python, whether it is passed by, generally there are two types, passed by value and passed by reference. There is actually in C++, if you take, there is pass by address and pass by reference, they are different. But here we are discussing this with respect to Python. So generally, if you take the passing parameters to function, there are two ways, pass by value and pass by reference. In Python, which one is used? But if you take C language, both can be used. Sometimes it is passed by value, sometimes it is passed by reference based on how you mention the actual parameter in call statement, but in Python it is not like that. So before I say what is pass by value and before I give whether pass by value is used in Python or pass by reference, we should know some concepts related with this in Python. The first concept is when you take here, you have to see there are two things in Python. One is mutable objects or mutable data. Another is immutable data. There are two things in Python, mutable and immutable objects. Mutable means it can be modified. Immutable means it cannot be modified. So if you take immutable, all standard data types, almost all standard data types like int, float, double, bool, string are immutable. Even if you take tuple is immutable. Whereas if you take mutable, list is mutable, dictionary is mutable. So the objects which we can modify are mutable. Some of mutable objects are list and dictionary. And if you take immutable objects, all standard data types, including strings, tuples, are immutable. Even set is a mutable object. So this is one thing you should know. So some objects can be modified. Some objects cannot be modified. What is that? It will be much clear when we proceed with this session. This is one thing. And second thing is how the values are stored in Python. See, in Python, as far as possible, some special cases it may have some duplicate values. In Python, as far as possible, it will avoid storing duplicate values so that the data can be represented in an efficient or compact way within the memory. This is one more important thing to note, how the values are stored. So this is one more important thing to note to understand passing of parameters. Now, if I take, suppose if I take C language, if I take int a equals to 10, int b equals to 5, int c equals to 10. Suppose if I have some statements in C, what happens is the memory is allotted to A. Of course, based on the data type here, 4 bytes is allotted, whatever it is, it does not matter. 10 is stored and A is named to this. And similarly, B is allotted with memory and another 4 bytes. C is allotted with memory, another 4 bytes. This is how it is represented in C language. I am comparing this with C because C is the most popular language, and most of the people, they start learning a programming language starting from C. So they may be learning other languages. The first language they learn is generally C, most of the people. So that's why I'm comparing. Now, if I take in Python, if you take the same thing, if I take, because there is no declarations in Python, I can straight away give the values to variables and I can write based on the value I give, the type is decided. So that is a different thing. I'm not bothering about that. Here, A is allotted with memory. Where it is allotted, it does not matter. A is allotted with memory. And here, one important thing to note is A is actually treated as a reference. It is a reference, a name. So A refers to this, it will be referring to this, and B is given a memory 5 and B refers to this. It's not address, in fact, it is just identifier or name. Now C, when you take, because it is having same value, there will be another name which you can treat it as an alias. So the reference you can treat it as alias. C is an alias to the same memory location. So this is one very important point to note, because based on this, you can understand the way of passing parameters to the function. So to represent the data efficiently, what actually Python does is it will not store the multiple copies of the same value. It will be having only one copy, and the remaining all are aliases or references to that memory location. Even if I say whether I write D equals to A or D equals to, sorry, semicolon is not required. D equals to A or D equals to 10, D is another reference to the same memory location. So this is how it is represented. Now, one more thing, just now I told you that integers, here I am referring integer values. The integers are mutable. For that matter, there are different mutable and immutable objects present in Python. The standard data types are actually immutable. So here integers are immutable. One important thing to note here is when I try to change a value, suppose if I say if I say A equals to 25, after some time, if I say A equals to 25, suppose if I do the same thing here in C, if I say A equals to 25, A equals to 25 later here, after this statement, if I write, what actually happens is this 25 is going to be modified because it is mutable in C, but in Python, because they are immutable, so what actually happens is, now another memory location 25 is created, another memory location 25 is created. Now A is no more a reference, A is identifier, but not identifier to this location. It is not identifier to this location, it is identifier to this location. So the important thing is, when you try to modify the value of a variable in Python, it will not actually, it will not overwrite the value referred by that particular reference, but it will create another memory location. Suppose if that value is not there anywhere in the memory, it will create another memory location, and now A is a reference to that memory location. So this is one important thing, because any immutable object, if you try to modify, what actually happens is the address of that memory location, or address of the memory location is going to be changed. In other terms, a new memory location is given, and A refers to that. So this is how the modification occurs in case of immutable objects in Python, because integers are immutable. So if you try to modify, the value referred by that name is not going to be modified. When I say A equals to 25, A is referring to location with value 20. This is not going to be modified. It remains same, but a new memory location is created with value 25, and A will be no more referring to the location with value 10. It will be referring to location 25. That's how the values and the data is managed in Python. Now, if you come back to the passing of parameters to functions in Python, now, I told you it is passed by value, passed by value, or passed by reference, here. Now, one point to note here is, in Python, everything is passed by reference. It is only passed by reference. There is no pass by value. This is one point to note. So there is only pass by reference present in Python. There is no pass by value. This is one point to note. Second thing to note is, everything in Python is object. Everything, whether you take standard data type or any other thing, everything in Python is object. So generally, if you take a generic programming term, the passing of parameter to functions is passed by reference. That means it will be clear what is passed by reference when I take the example. Generally, we call it as a pass by reference, but in program in Python terms, because it is only everything is an object, this is technically in Python, we may also call it as pass by object reference. Object reference. In general, I can simply say reference, but in Pythonic terms, you can say it is passed by object reference. So in Python, there is only passed by object reference. In another terms, in simple terms, you can say it is only passed by reference. It is only passed by reference. Now, if you proceed further, now suppose if I take one particular function related with this, what is going to happen there, I'm going to give. But here one thing to note, one more point to note before I proceed is, now normally in C, what do we say is when we say pass by value, when we say pass by value, what actually happens is a copy of the data item is passed, so that is true. And because we are working on the copy, there is no modification to that parameter in function will not be reflected on the calling function. But that is one thing. Second thing is if I take C, pass by reference means address is passed and will be working indirectly on the original variable, so modification will be reflected. But in Python, because the way the values are stored, it is different. So even though we say pass by Python, in Python everything is passed by reference. One thing to note here is because it is not sure that the value is reflected. That is one important thing here. Pass by reference, like in C, values modified will be reflected, but it is not like that in Python. Depending upon whether you whether the object is mutable or not, may be reflected or may not be reflected. So that will be clear when we take some examples here. Now, when I take here one example. When I take one example, so here I can say define. Otherwise, I'll write directly in the code. Ideally, I'll directly write the code instead of writing there in this. So I'll write here. So I'll say define something like pass data. Suppose if I take A. Now, if I take this, I'll say print A and ID of A. ID actually is used to know the address. This will indicate whether both are referring to the same memory location or not. So I'll say B equals to 10, and I'll say print. I'll say print B and ID of B. And then I'll call the function pass data. I'll pass B here. So this is I want to do. So what is happening here? I told you everything in Python is passed by reference. So I'll take this example, then I'll explain this. That is better. So what happens here is there is a variable B is created. So variable B is created. So here variable B is created. Memory location B is created with the value 10. Now, when I call this, it will be printed. So this will have some address. So it will print 10 and address of this. ID is used in Python to get the address. Now I'm calling the function here. I'm calling the function and passing B into A. Now everything in Python is reference. So A is a reference to an alias name. To reference means an alias, you can take it as alias. So A will be a identifier or an alias to the same memory location which is referred by B. So that's what happening. So now because it is same location, value is same, and if I try to print the address will also be same. So this indicates that it is not copy, it is not passed by value. If it is passed by value, another variable is created because there is no copy here. So it is only by reference. Both A and B are referring to the same memory location. So that you can clearly see from this execution. So I'm executing this. So there's you can observe both are referring to the same memory location. Both are referring to the same memory location. It is passed by reference only. Now, if I take if I take this, I may pause the list here. I'll take one more thing here. Pause define pause something like mutable. That is actually immutable. So I can take some value here, x. So I'll say print x comma id of x. Oh, it is the same here. So I'll take something like a list lst equals to, I'll say 10 comma 20 comma 30. So what I'll do is I'll print LST comma id of LST. I want to have two different functions, one which is taking some mutable thing, another is which is taking immutable. So I'll execute this again. I'll call this pass mutable. I'm calling both. So I'm passing this time LST here. I can use the same first function, but just I want to have two different functions. So I'll execute this. So here I have to give colon. I'll execute this again. So now you can observe, see both mutable or immutable, it is passed by reference. That is clear. One thing that is clear is everything is passed by reference. I'll take this again. I'll take this code again. I'll take the full code. I'll copy here. Just I want to copy this. Yeah, now it has come. So just here, what is happening is there is, I'll explain here, B is created in memory, B is created 10 and LST is created in memory with the values there. So LST, B is referring to this and LST is referring to a list with set of values. How this set of values stored, I'm not going to give. Now, when I call past data, A will be created, but it is just an alias. No memory is allotted for the value, so it will be referring to the same location. Then here X is created. Just I'm not taking sequence. X is created and referring to this. So this addresses whatever there. Suppose this is 2000, this is 3000. So the value and addresses are printed. So that's why we are getting same value here. Both the cases we are getting same value, because it is passed by reference. Whether it is mutable or immutable, everything is passed by reference. That's what I want to give. But when I change that, change the value passed, what is happening? That differs in mutable and immutable case. But the clear thing is, data is passed in Python only using pass by reference, not any other thing. So now I'll take again code. So what I'll do is I'll try to modify the data there. So if I try to modify the data, now I'll say a plus equals to whatever I want to give 100, I'll give. Then I'll try to print a value after modification and its address. Then I'll try to print the b value after I call the function. Then what is happening, I'm going to give here. Then similarly, I'll take the list here. I'll say x append, I'm modifying the list, I'm appending, so I'm appending 40, 40 here. I'll try to print the list after modification and its address. Then similarly, I'll print the list and the address after modification in calling function. So now it will be clear here. So here, when you take this, when I try to modify B is not, A is not modified. Actually, A is not when I try to modify A, it is not modifying value of B, because even though it's a reference, because modification is happening and it is immutable, new memory location is created. New memory location is created. And if you come back to the main remains same address, which is B, and value remains same. Now, if I take this, in case of immutable thing, the address is never changed. It is remaining same, and modification is happening within the function, and it is getting reflected. So modification depends upon whether the object is mutable or immutable, but the thing that is clear is in Python everything is passed by reference. Now I'll take this same code. I'll take this code and the values there. The result what we got. I'll take this and just I want to explain this what is happening there. So I'll take this again. So I'll take this. So I'll remove this space because I want to make it visible in one screen. So now everything is visible. Then what I'll do is I'll take the result also. I'll take the result also. I'll get it here. So I'll take result and get it here. So the result is this one. So now what is happening? This is the location. Assume that this is, I'll just take the last 4 digits of addresses. So there is a location 8096 where B is stored. B, there is a 10 and the location address is 8096 and B is referring to that. And then there is a list here. I'm calling the function, so I'll go according to the sequence. Now A is referring to the same location. A is referring to the same location. So when I print the value of this, I'm getting this, and when after I call this, I'm printing this. So I'm getting this result. So both are referring to the same location. Now I'm modifying A. When I try to modify A as A is integer and it is immutable. It is immutable. So what is happening? A new memory location with the 9776 is created, and the value there is 110. And A is no more reference to this. A is no more reference to this. A is reference to this. So a new location is created. So when I print after modification, when I print this A, I'm getting this result. Then I'm coming back to the function because B is remaining same. B is not affected. So when I print after coming back from past data, this is printing. So B is remain at 8096. Sorry, this is 8096. Remains at 8096. Value remains same. So this is what happens in case of immutable objects. So everything is passed by reference, but because the object is immutable, a new memory location is created that is not reflected. Now, when I take this statement, a list is created with address. List is created with address 8848. The list is 10, 20, 30. And LST is referring to this. LST is referring to this location. Then when I pass it, there is X created X is referring to the same location. Now X, the list is mutable. So when I print this here, I'm getting, sorry, before that I'm printing list. So I'm getting this when I print, then when I call this function and X is referring to the same list, I'm getting same result. The address remains same. Now I'm modifying X with 40. So 40 is added here because it is mutable. So the object value is modified inline. So when I print X after modification, I'm getting this. The location is remaining same. It is getting modified. Then when I come back after calling the function, I'm printing the list here. I'm printing this list. I'm getting back the same list and address is same, but the changes are reflected. So this is actually the passing parameters in passing parameters to functions in C. It is only passed by reference. So you should be aware of how the data is stored in Python, whether the object is mutable or not. So this will impact on the passing parameters, passed parameters, but only way of passing parameters to function is passed by reference. In Python, it may be called as passed by object reference. So that is about the passing parameters.